In this video, we'll talk about how to use trigonometric identities to verify relationships between trigonometric functions. The basic trigonometric identities are listed here. We have the Pythagorean identities. The basic Pythagorean identity is cosine squared plus sine squared is equal to 1. If you divide both sides of that by cosine squared, the result is the next Pythagorean identity. 1 plus tangent squared equals secant squared. If instead of dividing this first equation by cosine squared, you instead divide it by sine squared, you end up with the third. Cotangent squared plus 1 equals cosecant squared. Next, we have written the odd-even identities. This is just a restatement of the fact that certain trigonometric functions are odd functions and some are even functions. Cosine and secant are even functions. Sine and cosecant and tangent and cotangent, those are all odd functions. The cosine function is even and the sine function is odd, and we can verify that from the definition using the unit circle. The fact that the other functions are even or odd follows from the other identities on the page. First of all, we have the reciprocal identities, which tells us that secant is the reciprocal of cosine, and consequently cosine is the reciprocal of secant. Cosecant is the reciprocal of sine, and so sine is the reciprocal of cosecant. Cotangent is the reciprocal of tangent, and therefore tangent is the reciprocal of cotangent. How do we define tangent and cotangent? Well, tangent is sine over cosine, and cotangent is the reciprocal, so it's cosine over sine. Mainly what we'll be doing now is verifying new trigonometric identities. Here are some techniques for doing that. These may or may not help depending on what it is you're trying to show. Start with the more complicated side. Try to simplify it so it looks like the other side. Use known identities to help verify new identities. Combine fractions to reduce the number of terms. Factor out common terms. Convert everything into sines and cosines if possible. It's usually easier to work with sine and cosine, and the relationships between them often make it easier to see whether a certain statement is true or false. Here's our first example. Verify the identity here. Cosecant theta times tangent theta equals secant theta. So the way that we're going to do this is we'll start with the left side, which is more complicated. We'll rewrite it in terms of sine and cosine and then simplify. So we start with cosecant theta times tangent theta. Rewriting this in terms of sine and cosine, cosecant of theta is 1 over sine of theta. And tangent theta is sine of theta over cosine theta. Now we can see that the sines cancel. This leaves us with 1 over cosine of theta, which is equal to secant theta. Consequently, we've been able to show that the left side of the equation is equal to the right side of the equation, and so we have verified this identity. Our next example is here. 1 plus cosine theta times 1 minus cosine of negative theta is equal to sine of theta quantity squared. Once again, we'll start with the more complicated side. Everything here is already in terms of cosine and sine, so we don't have to change anything into cosine or sine. So we'll start with the left side of the equation. We have that 1 plus cosine of theta times 1 minus cosine of negative theta is equal to, well, what is it equal to? the first thing we observe is that cosine is an even function. So cosine of negative theta is the same thing as cosine of theta. Consequently, this product, 1 plus cosine of theta times 1 minus cosine of negative theta, is the same thing as 1 plus cosine of theta times 1 minus cosine of theta. So here we have 1 plus cosine theta times 1 minus cosine theta. So we can use the difference of squares formula to rewrite this as 1 squared minus cosine theta quantity squared. But according to the Pythagorean identity, this is equal to sine theta quantity squared. So now we've been able to show that the left side of the equation is equal to the right side of the equation, and therefore we've verified this identity. Let's do another example. Verify the identity that you see here. Sine of theta divided by the quantity 1 plus cosine theta plus the quantity 1 plus cosine theta divided by sine of theta is equal to 2 times cosecant theta. On the left, we have a much more complicated expression, so we'll start with that and try to simplify it so it looks like 2 times cosecant theta. And how should we go about doing that? The left side of this equation is the sum of two fractions, so what we're going to do is add them together, thus creating fewer terms, consolidating terms, as it were. So we'll give them a common denominator. So let's first write down the left side of the equation. So we have that sine of theta is divided by, let's make that a little bit straighter, is divided by 1 plus cosine theta plus 1 plus cosine theta over sine of theta. I'm just rewriting the same thing. This is the left side of the equation. Now these are two fractions, so I want to add them together. And the way I'm going to do that is give them a common denominator. So first we have sine of theta over 1 plus cosine of theta. The thing that this term needs is sine of theta in the denominator. So this is sine of theta divided by sine of theta. I have to multiply by sine of theta. I already have 1 plus cosine theta. I need a sine of theta. But in order to multiply by a sine of theta in the denominator, I need to do it in the numerator as well. So now we add 1 plus cosine of theta divided by sine of theta. So the thing that this term needs, this needs the 1 plus cosine of theta. So we multiply by 1 plus cosine of theta divided by 1 plus cosine of theta. It has to be in the numerator and the denominator. The next thing to do is to combine all of these terms. We have the same denominator now, so we can add them together. But we also have to simplify the numerator. So here we have a sine theta times sine of theta. So that's sine of theta quantity squared. So this is equal to sine of theta quantity squared plus, and now we multiply these two terms together, 1 plus cosine theta quantity squared. 1 plus cosine theta, all of that quantity squared, so the square of that sum. And in the denominator, we have the common denominator. 1 plus cosine of theta times sine of theta. All right, well, in the numerator, here we have a sine of theta quantity squared, and there's not much we can do with that now. But here we have 1 plus cosine theta quantity squared, so we can expand that. We can multiply it out. So first we have sine of theta quantity squared plus, and now the next thing we do is multiply 1 plus cosine theta with itself. So we're going to have 1 times 1 is 1 squared plus 2 times 1 times cosine theta plus cosine theta times itself. So cosine theta quantity squared. So we're kind of running out of room over there. So let me just move it over just a little bit so I can fit this in a little bit better. So let me just rewrite this cosine theta squared. So cosine theta quantity squared, well, let's just make that theta a little bit more theta-like, squared. Okay, and that's the numerator. The denominator, we're not going to really do anything with it right now, so we'll just leave it as 1 plus cosine theta times sine of theta. All right, well now what have we got in the numerator? Well, 1 squared, that's just 1. But we also have a sine theta quantity squared and a cosine theta quantity squared. Sine squared plus cosine squared is 1 by the Pythagorean identity. So if we add those together, we end up with 1 plus 1 squared, which is 1, plus 2 cosine theta. And all of that divided by 1 plus cosine theta times sine theta. So again, we're not doing anything to the denominator. So just to be clear about the 1's, this first one came from sine squared plus cosine squared. That was equal to 1. The second one came from the 1 squared. So let me just change the color of the highlighter. So this 1 squared is that one. And then we didn't do anything with the 2 cosine theta. We just left that alone. So 1 plus 1 is 2. So we write this now as 2 plus 2 times cosine of theta divided by 1 plus cosine theta times sine of theta. And now we just notice that if we factor a 2 out of the numerator, we're going to have a factor of 1 plus cosine theta, which we also have in the denominator. So let's just do that. So we factor out a 2 from the numerator. 1 plus 1, no, sorry, 1 plus 1 times, but 1 times cosine theta is just cosine theta. And this is divided by 1 plus cosine theta times sine of theta. And now the 1 plus cosine theta in the numerator cancels with the 1 in the denominator. And we're left with 2 in the numerator and sine in the denominator, sine of theta. Well, sine of theta is cosecant of theta, or excuse me, 1 over sine of theta is cosecant theta. So this is 2 times cosecant theta. And that's what we were looking for, 2 times cosecant theta. So we've managed to show that the left side of this equation is equal to the right side, so we did manage to verify this identity. Here we have another identity that we wish to verify. Secant theta minus 1 divided by secant theta plus 1 is equal to 1 minus cosine theta divided by 1 plus cosine theta. Here I wouldn't say that any one side is more complicated than the other. However, the left side has secants in it and the right one has cosines in it. So let's take the left side and rewrite these secants in terms of cosine and see if we can simplify to make it look like the right side, 1 minus cosine theta divided by 1 plus cosine theta. So we'll start by writing down the left side. Secant theta minus 1 divided by secant theta plus 1. What we're going to do next is just replace all of the secants with 1 over cosine. So secant of theta is 1 over cosine theta minus 1. And this is divided by secant theta, but again, secant theta is 1 over cosine theta plus 1. So next we're going to write all of these over cosine. So here we have a 1 over cosine, and here we're subtracting 1. So we're going to rewrite this as cosine over cosine, so we can give these two a common denominator. We're going to do the same thing in the denominator as well. We'll replace that 1 with cosine over cosine. So this is going to be 1 over cosine theta minus cosine theta divided by cosine theta. And all of this is divided by 1 over cosine theta plus cosine of theta divided by cosine of theta. So in the numerator, if we combine these, they both have the same denominator. So if we combine these, we'll have 1 minus cosine theta divided by cosine theta. That's our numerator. And then we're going to divide that by this denominator. So again, we're going to combine these two terms, so we'll have 1 plus cosine theta divided by cosine theta. So here we have a fraction divided by another fraction. Dividing one fraction by another is the same as multiplying it by the reciprocal. So 1 minus cosine theta divided by cosine theta. So instead of dividing by, well, let's write it out as division like this. Divided by 1 plus cosine theta divided by cosine theta. So all we've done here is rewrite it. We haven't actually done anything yet. We had this term divided by another term. So 1 minus cosine theta over cosine theta divided by 1 plus cosine theta over cosine theta. So all I've done here is, instead of writing it with a horizontal bar, I've used the division symbol. So it's the numerator divided by the denominator. The reason I would do this is we can see that we have something that we're dividing by a fraction. So that's the same as multiplying by the reciprocal. So this is equal to the first term, 1 minus cosine of theta, divided by cosine of theta. And now we're multiplying by the reciprocal. So that's going to be cosine of theta divided by 1 plus cosine theta. And now we notice that there's a cosine in the numerator and the denominator. So those will cancel, and we'll be left with 1 minus cosine theta divided by 1 plus cosine theta. And that's the thing we were looking for. So we've shown that the left side was equal to the right side, and therefore we've verified this identity. Let's do another one. For this example, we want to show that sine of theta raised to the fourth minus cosine theta raised to the fourth is equal to 1 minus 2 times cosine theta squared. This is our objective. So let's start with the left side and show that it's equal to the right side. So we have sine of theta, and we're raising all of sine of theta to the fourth, minus, and now we're going to raise all of cosine theta to the fourth. So here we have a sine to the fourth minus a cosine to the fourth. We're going to rewrite this slightly as the difference of squares. So this is equal to, so we're going to have sine of theta quantity squared raised to the 2 power minus cosine theta quantity squared raised to the 2nd power. So here I have a sine squared quantity squared. So if you raise an exponential to an exponent, you multiply the exponents together. So you'll have sine to the fourth. Here it's cosine squared raised to the 2 power. So again, I have an exponential that I'm raising to an exponent, so multiply the exponents together to get a 4. So it's cosine squared quantity squared. So that's the same as cosine to the 4. Okay, now the reason that we did that was to recognize the expression as the difference of squares. So I have something squared minus something else squared. So this is the difference of squares. So now I'm going to rewrite it that way. So we're going to have sine of theta squared minus cosine theta squared times sine theta squared plus cosine theta squared. So here we're using the difference of squares formula. So the difference of squares formula says that if you have some quantity a squared minus b squared, that's equal to a minus b quantity times a plus b. quantity. And in this case, we're letting a be equal to sine of theta squared, and b is equal to cosine of theta squared. So we have a squared minus b squared. So that's going to give us a minus b. So a is sine of theta squared minus b, but b is cosine theta squared. And then this is times a plus b. So sine of theta squared plus cosine of theta squared. Okay, so what good does that do for us? Well, here we have a sine squared plus cosine squared, and by the Pythagorean identity, this is equal to 1. So this quantity right here, that's equal to 1 by the Pythagorean identity. So that tells us that our expression is equal to sine of theta squared minus cosine theta squared times 1, which of course is just sine of theta squared minus cosine theta squared. So what do we do next? Well, we're going to actually use the Pythagorean identity again, but we're going to use it on this sine squared term. So let me just change the color here. So we know that cosine of theta squared plus sine of theta squared equals 1. So we're going to solve for sine of theta squared in terms of cosine of theta squared. So sine of theta squared is equal to 1 minus cosine theta squared. And I'm going to take this value and I'm just going to plug it in right there, because I have that sine of theta squared is equal to 1 minus cosine of theta squared. So we're going to end up with, this is equal to 1 minus cosine theta squared minus cosine theta squared. And we're multiplying all that by 1, but that's just going to give us the expression itself. And now we notice that we have a 1 minus cosine theta squared minus another cosine theta squared. So what do we have? We have 1 minus cosine theta squared minus itself, so it's minus 2 cosine theta squared, and that's exactly what we were looking for. 1 minus 2 times cosine theta squared. Same thing. So we were able to verify this identity. Let's do one more example. Let's verify this identity. Sine of theta plus 1 divided by cosine theta plus cotangent theta is equal to tangent of theta. Let's verify this identity. We'll start on the left side because it's more complicated and see if we can make it look like tangent of theta. So we start with sine theta plus 1 divided by cosine theta plus cotangent of theta. The next thing we'll do is rewrite this in terms of sine and cosine. Well, most of it already is in terms of sine and cosine, but here there's a cotangent. So let's just rewrite that in terms of sine and cosine. So the numerator is sine of theta plus 1, and the denominator is cosine of theta plus, and cotangent is cosine over sine. Cosine theta over sine of theta. Okay. So this is equal to, so the numerator, we're not going to do anything to it. The denominator, I'm going to combine these terms. So in order to do that, I need to give them a common denominator. So there's a cosine theta. I need a sine theta in the denominator. So this is going to be cosine of theta times sine of theta divided by sine of theta, plus cosine of theta divided by sine of theta. So for this term, you can see that the sine of thetas would cancel and you just have cosine of theta. But we wanted to do this because we wanted to give these terms in the denominator a common denominator of their own, which is sine of theta. So now we're just going to combine these by adding them together. So in the numerator, we have sine of theta plus 1. And in the denominator, we're going to have cosine of theta times sine of theta plus cosine of theta And all of this is divided by sine of theta. All right, let's put brackets around this. By putting brackets around it, it makes it more obvious that that whole term is in the denominator. Let's also extend our line like this. Let's just rewrite it, or redraw it, I guess. So this is going to be like that. Okay, so now it's a little bit more clear that this entire term is in the denominator. Well, again, dividing by a fraction is the same as multiplying by the reciprocal. So let's rewrite this as sine of theta plus 1, and instead of dividing by that fraction, let's multiply by the reciprocal. So we're going to have sine of theta now in the numerator divided by this longer expression, cosine of theta sine of theta plus cosine of theta. Okay. So we took this term in the denominator, this fraction, and instead of dividing by this fraction, we're multiplying by the reciprocal. So the sine of theta is now in the numerator, and this cosine theta sine of theta plus cosine theta, that's in the denominator. Well, notice that we can actually factor out a cosine theta in the denominator now. So let's do that. So let's write this as sine of theta plus 1 times, and we have a sine of theta, and we're going to factor out a cosine theta. Cosine theta. That's going to leave us with a sine of theta plus 1. So what we did is we just took that cosine of theta and factored it out. But now we notice there's a sine of theta plus 1 here and a sine of theta plus 1 there. So those cancel, and we're left with sine of theta divided by cosine of theta, which of course is tangent theta. And that's what we were looking for. We wanted to show that this initial expression, sine of theta plus 1 over cosine theta plus cotangent theta, we wanted to show that that was equal to tangent, and we just did. We showed that it was equal to tangent. Therefore, we verified the identity.